Good evening, ladies and gentlemen. This is Michael. I'm in my hotel room in Nairobi. I came with a team of a team of 5. We came from Kampala to have inspection and also engagement with Zenith steel factory fabrication in Nairobbi. Definitely our interest is we are trying to find a way of collaborating with industry practitioners, fabricators, designers, in a way that we try to do design with what is already available in the market, at the South African market. Zenith seems to be one of the biggest factory fabrication in Africa here. But why are we here? The interest is basically in about 4 or 5 areas. We are only trying to acquaint ourselves. We want to learn a few things on how the bridge plate girders are fabricated. Right from when the design is done, and then it's passed on to the contractor. The contractor is always asked to generate what they call workshop drawings. So if you look at steel plate girders, well, let's say it is steel composite, of course, but we are more interested in the plate girders. Concrete now comes when you're on site construction. So you find in a plate girder you have the sear studs, which are welded onto the flange or flanges of the steel plate girders. We have the plate girders if the span of the bridge is more than standard sections of 12 or 11, then we have splice connections, which are always bolted. And then we also have welds, because the top flange and bottom flanges are always welded onto the web. And then we also have stiffeners and the bearing support and also the mid span. So you are aware we have grades of steel for concrete. We also have grades of weld. We have weld sizes. We have weld length. We have weld defects, and then also, and especially in steel composite, welds are basically stress risers. These are areas that, due to cyclic loading or fatigue, you can expect generation of crack in the highest time of the bridge surface. So we want to see the process flow. We want to see how do they fabricate these plate girders. Do you even have precamber? How do they test for weld? How do they fabricate sear studs? How do they check for this weld? And non-destructive testing and destructive testing. What quality control and quality assurance are in place to ensure that these plate girders which are being fabricated do stand the test of time. And you remember most of our bridges are designed for at least a minimum of 100 years design life. But with proper interventions, service life should be slightly more, about 150 or even more, depending on how we follow how old these bridges. So there's this thing of the bridge lifespan depends on, of course, maintenance depends on, but also the way we protect this structural steel against explosion. How do we limit ingress of contaminant that will trigger rusting of the steel or what we call. So there's where we talk about hot dip galvanization, and there's also cold. Then there's also application of paint, a different paint. All this, if it is hot dip, it has its own maintenance free life. How long does it take for that not to work? And then if it is cold, which is spray type, the quality of spray is different from when it is dipped. And then also when you do paint has got its own maintenance free life. So some of the things determine the maintenance intervention, the regime, and basically the cost. If you hot dip, it may go to 75 years or even up to its lifespan without experiencing any of the serious corrosion. Or if it is spray type, you may find that every 20 years or even 15 years you have to spray again. Now when you accumulate this cost for so many times to make it an equivalent one-off galvanizing using hot dip, you may find that the cost of maintenance definitely will overshoot what was anticipated at the time. So some of these things help us. So we are here, we also want to know, we just want to appreciate, learn, because there's a lot of material sciences, a lot of durability aspect considerations that these guys do undertake. So that is why we're here. We're just trying to follow it. Do they do some design checks? If they do, because normally the engineer does the design, contractor does the fabrication drawings, they feed it, they give it to the fabricator, they check, they give it to they feed into the system, and the system, we said, do the thing we need to know from the receipt of our drawing of our software, what happened after delivery for installation. Remember, our principle on site is that we need site bolting, and also most fabrication must be done to completion at the factory, because you have control condition, flame cutting, so many things that they do, and checking if there are no defects in the way. Even this precision cutting of the hole, drilling of this hole has to be done. You cannot do it from site. So, because the design is done to certain criteria and requirements, so that is what we want, the condition which is controlled. That this member, splice connection, the went are all done under that condition. So that's why we're here. We are going to follow these guys tomorrow. They will take us to site, have a look at it, appreciate what they do. We also had a brief meeting, and we told them how do they bring on board students, so that we begin to introduce some of this subject early enough to our students at the university, colleges, and this, so that now they understand. You know, we have very bright young people that leave primary with all the distinctions. When you go to secondary with all the distinctions, they go to A level with very good grades. Now they go to university, they come out with distinctions, first class degrees, upper second, but as soon as they begin work, it's a struggle. It's like we're going back to nursery. But this nursery now is a journey of industry practices. Everything looks new nowadays. So it is important now that curriculum is changing, that people get enough. We need interaction with the industry, best practices, practitioners, understand what they do, relate to the theory. Even they have to refine the syllabus. Some people may not want to do Fourier method, Fourier series. Some people may not want to do Laplace method. Others may need this basic engineering mathematics, and then so they need to understand that. So I think we are here briefly when we are going to that engagement. Definitely, as government workers, and of course, this interaction help us to appreciate what they do, but not that we are out to outsource it to get work in the rest of it, because the policy is clear for most of these government projects that you come through contracting, you come through procurement, you can even come through your contracting, facilitation, and financing, or you can also do your PPP thing, or you pre-finance, depending on the financial terms agreement with the ministries, HIV in Kenya, Tanzania, and but it's very important that we, the technical, begin to interact with the industry, appreciate, and so that we all understand and have the same language, and then we proceed. That is something that I thought I should briefly talk about when I'm in this Nairobbi hotel room. So we are here. Thank you so much, you guys. I will update you guys after our engagement tomorrow. But key to this is, if you're a designer, you need to have these compelling factors. What is it that, if it is not done well, my design life I've specified for this bridge A of 120 years may not be achieved? So you look at the wells, you look at the ball grades. Are they the one that these guys have? Are there ways of testing these balls? Are there ways of testing the well? What about testing? What about checking the quality of and the procedure and processes of galvanization? Is it what it is? If not, what need to be done? Are there any innovative approaches to construction of the new generation plate girders? We are more into the 3, 4, 5, 6, 7 girders. But can we get high grade and we do only 2 girders? I've seen the Japanese have already gone into twin girders. We're using high grade. So what about starting to use our local materials? In Kenya here, you have now the Zenith, maybe, and others sister factories. You also have in Uganda, I think, you have roofings. We have Uganda Bati. They deliver. So there are those medium plate and roll sections that can be converted into truss system, and short span bridges that can be actually locally manufactured and designed for, that can take up our traffic on the local roads or rural roads, and then also flyover for footbridges. So some of this interaction may open that door, and then we begin to appreciate. Then tomorrow, 1 or 2 of us, if you find yourself into at a higher level, or commenting or advising your managers and supervisors on what needs to be done, at least you will now aware that at least in Nairobbi we have these guys, in Uganda we have them, and also Rwanda, I'm told planning to open one in Rwanda, in Tanzania, that's Dar es Salaam, they have. So it's very important. I have seen the need to interact with the student a lot. Right now, as we speak, we already introduced Makerere University to Minders IT India. They have installed the Minders software. They have an MOU. And as I speak, the Master of Structure students have all gotten this, and they are going to embark on the understanding of modeling procedures, steps required, so that they relate to the theory. And by the time they finish the projects and the rest, they will have modeled, they will have analyzed, loaded, and when they come out, they add value to our design industry, construction industry, and they begin to appreciate, and the younger generation begin to pick interest, and that is how we can move on and we can have that confidence and move with people. We shall always do things knowing that out there we have the factory which can fabricate. The factory also knows that actually the university is actually now channeling very well aligned students. So that's why we're here. There's a lot more here. We are here for lesson, for learning. We shall pick some lessons. We shall go take some information back home and share with people. Share with our managers. Share with our permanent secretaries. Share with the ministry. Share with those who are in need. And also, maybe they can have further collaboration in future, and we shall begin to see exchange of students in terms of who go to your ministry. They can also get ways that is more like what they call like immersion or something like that, where they can send them to Nairobi for 1 week, get to understand all these things, then after 1 week they go back, continue with other normal training, but at least they get what they call that global understanding, global confidence, and they work on towards that. Plate girder is the subject. Different plates. You have the top flange, you have the web, you have the bottom flange, you have the stiffeners, we have the sear studs, we have the splice connections. These are all connections. They are connected to give you a complete plate girder ready for formwork and concrete. But how do you connect these and connected members. What quality control deliberations do we have at the fabrication workshop? Qualifications, capacity, capability, equipment, procedure, process flow, flow charts. That's why we are here. We're here to learn. If you're around the corner, please pass by tomorrow. But of course, with their permission, we can come around and learn a few things. We are here to learn and relate with what we do. Thank you. Good night. I'm in Nairobbi.